This is Dipti Roy here. So yeah, Nitesh has already set up some context about what are the finite state machines and how we are going to use it in UI. So here I would just like to take this opportunity and extend the concept further and take this concept towards the server-driven UI. So we all have read the automata in our engineering, right? So what are finite state machines? So just a quick real recap of what are finite state machines. So we can take it as an example, right? That we can take an example of the lift, right? A lift can move from the 5th floor to the 6th floor. It can move to the 10th floor, and it can even move to the first floor or the other floors. It also has the ability to stay on the same floor also. Like you can keep clicking on the open button, and you will stay in the same state as you are. Along with the infinite states that you can go in, you all also have the ability to stay in the same state because some of your requirements and some of your validations are still not complete, and you need to complete all those requirements before you move on to the next stage. So that is what finite state machines are in a very short definition. So what is our use case and what are we trying to solve here? So this is a very theoretical description and how it is going to simulate sequential logics. So let us put it in our developer life, like how it is going to help us. So here I would take this opportunity to take an example of PayPal in this particular scenario. What we are trying to achieve in PayPal with finite state machines. So in PayPal, we have so many countries, right? And so many countries have so many regulatory policies. There is KYC for India, and similarly there is CIP for US. There are different many policies that still exist for US for other business accounts and operating accounts. So there are infinite capabilities, and this is not something that PayPal has enforced. This is the government obligations that needs to be completed before you are able to basically move forward and operate your account. Even in India, you must have seen that when you're operating an account and you are actually exceeding certain limit, so you cannot do that before validating that are you, what the user you are, and what your real identity is. You can be a fraud or something else. So we need to validate you because you are doing such large transactions. And since we all and on such a high level, when we are operating with PayPal, so we need to make sure that we need to extend these solutions to so many countries and so many policies. So how are we going to scale this? We cannot develop one solution, then again build it for some other solution and keep building it, so on and so forth. It might happen that the business requirements keep changing. Our product managers and our designers want to say that, okay, the date of birth should not be there after address, it should come before, and we need to change that sequence in the UI. Or it might happen tomorrow that SSN, let's say for example, that is very specific to US and it does not exist in India. So are we going to build different capabilities for each country and for so many other policies that are existing? No, right? So our solution to this particular problem is a server driven UI approach. And what are we going to achieve with that is, so the first one is very simple, that we want to achieve a server-driven UI where all the logics are completely driven by server. So how it is going to help us? We are completely separating our business logic from it. We are reusing our React components, and like we all know, the biggest problem in the front-end world is the bundle size. So as we are moving towards reusing React components, we are moving in the direction, we are not trying to increase the bundle size at all, no matter whatever the scalability comes into picture. And the last one is that it is highly configurable. Like I told you, the example of the business requirements and the product and the design requirements, coupled with the government obligations. So come what may be, we are highly configurable, and we are not going to take our front-end release every now and then. We are trying to keep this process as smooth as possible, and we are just going to drive it everything from our server. So this is what we are going to achieve with that. So what does Machina fit in all these pictures? What is Machina? Machina is a JavaScript framework which is going to help us in achieving this finite state machines. So just a quick basics of how we can use Machina. There are two very simple things that we need to remember always when we are using Machina, is that one is the finite state machines, basically which will tell you what kind of transitions needs to be there, where you need to stay in, whether you need to move forward or you are not actually validated. There are some data elements missing and you need to stay in the same state. The second is the FDD. What is FDD? It is a unique identifier for the flow. So, like we have USCIP, we have India KYC, we can have US FATCA, and so many infinite policies and countries. So, there has to be some unique identifier which will tell us that, okay, this is my identifier, and these are my states for this particular identifier, and this is how I need to move in this particular scenario. So, the unique identifier for the flow is going to help us achieve in that direction. So, how does the unique identifier look like? So, I'll just move on to the code piece and try to give some basics of how you can get started with Machina and implement this in your own code base. So, here in my FDD, which is, you can just say that it is a unique identifier, I have this identifier which is USCIP. So, the main important thing to remember is that we can have a parent FSM and we can have the subsequent child FSMs. What does this mean? It means that in a particular flow, we need to decide that first we need to collect the personal data, we need to then collect the business data. Now, in personal data also, there could be so many infinite fields. There could be date of birth, there could be SSN, address, mother's name, and so many different fields, which may or may not exist for other countries and other policies. And so on, we need to drop these things from that particular validation. So on a parent level, we need to decide that how our transitions is going to be like. We can have a consumer, we can have a merchant. So if it is a merchant, we need to collect the business data. If it is not a merchant, we need to skip from personal data to the success page directly. So this is what our parent FSM will tell, that how we need to move from one state to another. We need to define this parent FSM and tell how the structure is going to be. And subsequently, these are our child FSMs: business type, personal data, and success. These are our child states basically, which will tell that what we need to do in this particular child. So, on a very high level, how our parent FSM is going to look like? What are the keywords that we need to remember when we are writing the parent FSM? The first important thing is the initial state, that once we have entered the flow, what it is that we need to start with, what is it our init process that it's going to be. So the initial state is important, and subsequently you have to define all your states, which is going to define this particular one flow of policy. So we can collect the business type, whether it is consumer or merchant. We need to then decide that once this particular child, like I told you, that these are the child states that are there. So this is defined as a child, and the subflow is the business type. On enter, we need to initiate, and again, this particular child is going to have its set of own FSMs, that what this particular child will need to do. And once this particular child has completed all its validation, the data collection, and the persistence, and everything is right, he will move to the next thing. This particular child state will be completed, and this parent FSM is telling that, okay, from this state, I now need to move to the personal data state. So this is the parent FSM and how this looks like. At the end level, we reach a success page. Once we are completed with everything, we are saying that we are done, and then it reaches the success page. So this is the flow, and this is the states that it looks like. And it's not like that it has to go sequentially. It has to move from this one to this one, and it can skip the states. It can remain in the same states. And that is what the finite state machines is going to help us achieve in that. Very briefly, how our child FSM is going to look like. The parent FSM is only going to contain the state transitions and how the transitions are going to be. But what is the business logic, and what all things are there that we need to do on that particular page? What are the data elements that we need to collect? What do we need to persist? And if it's, say, it's a national ID validation, national ID number. So we need to validate that, okay, for Denmark, we needed to have it as a 13-digit number. The user cannot enter more or less. So those kind of validations, whether they are fulfilled or not, we do that in the child FSM. So this child FSM is completely dependent on the child state that we are into. It has nothing to do with any other states in the parent FSM. So very quickly, how will our business logic in the child FSM will look like? So in the child, again, it will follow the same process like we did in the parent FSM, that we are going to have an initial state, and then subsequently we are going to have n number of child states for this one also. Just the difference that it's going to be there is that in our parent FSM, we are trying to say that what kind of transitions, proper state transitions that is going to happen. But in our child, it is the small business logics, the small UI element logics that we are going to write, and we are going to say that, okay, this step is done. Now we need to move to the next step, and so on and so forth. So the keywords here to remember are that there are the handlers. Similarly, like the parent FSM, we have the initiate thing, and here executors are there, which is different from the parent FSM. So executors are basically having the business logic. Executors will tell that what all things, what all the JavaScript logics we need to execute, and the only return functionality of this function, it will perform a lot many things, but there is only two things that this processor can return. The first is whether it was completed, like it was success or not, or it was a failure, like it was incomplete. So if it is completed, that means that we are done and we can move to the exit state. We are successful and this particular child state is completed. But let's say some validations or some logics are failing, even though the all the data is filled, this particular thing is still in the incomplete state. And this means that, like there is in a FSM, right, there we can stay on the same state, like in the lift we can stay on the same state, and we have to complete the requirements so that we can move to the next state. So this is how the transitions for the child business logic FSM will look like. And once this particular child logic has completed all the states, it will move forward. And once it is a success, it will again give the control back to our parent FSM. The child state is completed, and this will say that now the child substate is completed, and the parent will now decide that what further we need to do with this particular state and how the transitions are going to look like. So this was what is the FDD, which is a unique identifier for our Machina. Moving on to the next slide, this FSM slide is already what is something that I have explained in our code base, that how our parent FSM is going to look like and how our child FSMs is going to work. So this is just that. So now the question comes that how does the one state machine will look like on a very small and very minute level, how you can use Machina, and what is the two things that you can take away from this talk and remember while you are implementing Machina. The first one is that you need to define the initial state, where you are starting and what you want to start with, and then subsequently the child states. You need to remember these two things and you can just get started off with Machina. So on a very high level, how the holistic view of this particular flow will look like. The first one is that we need to give the key identifier for the flow. Then comes the child, the parent and the child FSMs. We have to define the initial state and the transition states. And these three are the subsequent FSM logics. Like we have handlers. Handlers are there for the parent FSM, which will tell the next state transition, and executors are there for the child FSM, which is going to give you the business logic and whether that completion has been achieved or not. And once these things are achieved, what is the next state that we need to define and where we need to move in. So this is the holistic picture of Machina and the state machines that looks like. So what is the advantage? We already discussed some kind of advantages in our initial slides, but apart from all the advantages of scaling the solution to different countries and policies and all those things, driving it from the server, there is one further advantage that comes from our experience from the product managers, from the design, that they will say that we need to remove the UI elements. We don't want to have it like this. We need to have it like this and that, and we can reconfigure everything. But we do not need to touch our front end, our React components at all. And we can remove, we can add, we can tangle, we can do anything that we want to in this particular screen, and it will be server driven. So that is the advantage that we are having with the state machines. So yeah, that was all from my side. Thank you guys for having me in React Bangalore. Thank you.